Hey everyone, welcome to the final video in our series. I know it's been a long one, but we are right at the tail end now. So today we're going to apply everything we've learnt from those really hard questions involving algebraic fractions and simplifying them, and we're going to apply this to solving equations, a skill that we've learnt previously in the past. Now once again, these things look really scary at first, but as long as we apply everything we've been doing up until now and just follow those steps, it actually ends up making the question a lot easier. So let's jump straight in with this first example. Now we're asked to solve this equation. Now if you notice on the left-hand side of this equation, this is an addition of algebraic fractions, and we already know how to do these. Now what makes this question hard is up until now we've only been able to solve things looking like this, for example, where we know what to do when we just have one fraction and we need to solve the equation, but now we have two. So what we want to do is we essentially want to consolidate both of these fractions, add them all under the same denominator. And we already know how to do that from the videos previously in this course. So what we're going to do, once again, we want to find the lowest common denominator between these two here. Once again, I'm working through this a bit quicker because I assume by now you'd be quite comfortable with adding these algebraic fractions. So our lowest common denominator is 6 here. So we basically want to get this 3 to 6 by multiplying by 2. And this 2 to 6 by multiplying by 3. And I sound like a broken record now, but we're going to do the same to the top because we want equivalent fractions. What we do to the bottom, we have to do to the top. So now we have 4x over 6 plus 3x over 6, and that equals 7. And now because we're adding fractions with the same denominator, we can just express this as one fraction. So this I can rewrite as 4x plus 3x over 6. And also, we now know because we have both x terms on the top, these are algebraic-like terms. So we can add 4x and 3x. That's going to give us 7x on the numerator here. And we have an equation that looks like the ones we did back in year 7 and year 8. Once we add the two algebraic fractions and consolidate them into one, it becomes a lot easier. It becomes a question we're quite familiar with. So now what we want to do is, I'm going to work through this quicker because by now I'm sure everyone knows the basics of solving equations. I want to do the opposite here. So I have 7 timesing by x dividing by 6. So I'm going to multiply 6 to both sides to figure out what 7x was before getting divided by 6. That equals 42. And then I want to divide both sides by 7 to leave me with my x. And here I get x equals to 6. The solving equations bit, we'd all hopefully know by now. The hardest part of these types of questions is applying what we know about adding algebraic terms to one another. So if we move on to this next question, we kind of want to do the same thing. It's a little harder because we have binomials on the top, but the same principles still apply. Even as these questions get harder, we're still using the same tools we have done up until now. So the lowest common denominator, the smallest number that both 3 and 5 go into, is 15. So this 5, I want to multiply top and bottom by 3. And here I want to multiply top and bottom by 5. So here I get both of these denominators are 15, so let me just write this as one big fraction with a denominator of 15. And now here, once again, it's important to note 3 is multiplying by x minus 2. We're treating that as its own term, and we can show that by putting brackets around it. So this is like saying 3 multiplying by x minus 2 here. And from that, we're subtracting 5 multiplied by x minus 1. And that equals 1 on this right-hand side. And now this is a much more standard, kind of stock standard equations question. Because we have one denominator, I can actually get rid of this denominator, can't I? Just by, oops, that's meant to be 15. And I can multiply both sides by 15. And that'll give me just this numerator on its own. So I can do the opposite of dividing by 15. It's the same thing that we've been doing up until now in terms of equations. And I get left with 3 outside of x minus 2 minus 5 outside of x minus 1 equals to 15. And here I just want to expand the brackets now. So my 3 is going to interact with both of these terms in the brackets. My 5 is going to do the same. And I get left with 3 times x gives me 3x. 3 times negative 2 gives me negative 6. Minus 5 times x equals minus 5x. Minus 5 times minus 1 gives me positive 5 equals 15. Okay. Now, finally, pretty easy by now if we've been following with the equation things from year 7 and year 8. All we need to do now is add the like terms. So 3x minus 5x is going to give me minus 2x. And minus 6 plus 5 gives me minus 1 equals 15. And now I just want to isolate the x. So doing what we've been doing until now with equations, I'm going to plus 1 to both sides. That gives me negative 2x equals 16. And then I'm going to divide by negative 2 because they're multiplying here. So I want to find what number multiplies by negative 2 to give me positive 16. And if I divide that through, I get that x equals negative 8. And that is my solution. And now, you can see the questions are cycling through all of the different combinations of adding algebraic fractions that we've come to terms with so far. Now they're going to get a little harder, but the same ideas still ring true from the previous videos. As long as we understand the process and how these fractions work, and they work just the same as regular fractions, we can be in a good position. So now, we have algebraic terms on the bottom. So our lowest common denominator is likely going to be an algebraic term. So what is the smallest thing, the smallest expression that 2x and 3x go into? Well, the smallest one here that we can get that'll make it simpler for us is both of these can go into 6x. Right? Because 2x goes into 6x a certain amount of times, and I can make 3x into 6x too. This is the smallest denominator that we can possibly have. So how can I get 2x to 6x? Well, I just want to take 3 lots of 2x. So I'm going to multiply by 3, top and bottom. And to get 3x to 6x, I'm multiplying top and bottom by 2. So now, I wind up with, on the numerator, I get 15 minus 8 on top of 6x. I've just consolidated these a little sooner, but I get 6x on the left fraction, 6x on the right hand fraction. So because they're under the same denominator, I can make this into one fraction. That equals 2. And then 15 minus 8, well, I know what that is. That's going to be 7. So let me rewrite that as 7. And now I just want to solve the equation. So I want to get 6x on its own. So what I'm going to do is I can multiply it over to the other side. If my 7 here is getting divided by 6x, or if I multiply both sides by 6x, that'll give me it on its own on one side. Then I can work from there. So my 7 stays here on the left hand side, and my right hand side becomes 12x. And now I just want to get x on its own. 12 is multiplying by x here, so I can just divide both sides by 12, and that will leave me with x on its own on the right hand side, and on the left hand side I get 7 divided by 12, and that is my answer. So we don't need to get too tripped out just because the x is on the other side here. That's something new. We still go through it the same way. And the solving equations part is all about just stripping away at all the layers to leave me with x on its own, or our unknown pronumeral on its own. Okay, this is our very last question for today. And once again, we've built up, now we have a binomial on the denominator. But that's okay, because here, well, because all of the other questions, we have been adding and subtracting algebraic fractions. We know how to do that. So why don't I try to get this term here on the left-hand side? I'll get them together so I can add or subtract. Now, this is a positive 2 over x minus 4. So I'm going to subtract this from both sides. So I'm going to subtract 2 over x plus 4 from both sides. And I'm going to wind up with 3 over x plus 1 minus 2 over x plus 4. And if I subtract 2 over x plus 4 from itself, I'm going to get 0 on the right hand side. Now, what do I want to do here? I want to find, once again, the lowest common denominator. And if you remember from the last video when we looked at some harder algebraic fractions questions, we said that if we have completely unknown terms with which we can't find the lowest common denominator, that denominator can always be a product of the two terms. So my lowest common denominator can be x plus 1 multiplied by x plus 4. So here I want to get x plus 1 to x plus 1 multiplied by x plus 4, well, I'm going to multiply by x plus 4. I'm going to times this by x plus 4. And I'm going to do the same to the top. And on the right hand side, well, sorry, this second fraction on the right, I'm going to multiply, that by x plus 1, and the bottom by x plus 1. So what do I get left with? Well, I get 3 times x plus 4 minus 2 times x plus 1 over x plus 1 times x plus 4, and I get 0 on the right hand side. Now the really useful thing about having this 0 on the right hand side is I can multiply through by this to the other side to find what this thing is equal to, just by doing these opposites, by doing what I've already been doing with solving the equations. So I'm going to multiply both sides because it's being divided by x plus 1 times x plus 4. I'm going to multiply both sides by this. And the neat thing here is because the right-hand side equals to 0, anything that I multiply 0 by still becomes 0. So I wind up with the thing on the left, 3 outside of x plus 4, minus 2 outside of x plus 1, equals 0. And then I can just expand the brackets. So 3 times x gives me 3x. 3 times 4 gives me positive 12. Negative 2 times x gives me negative 2x. And negative 2 times 1 gives me negative 2. That equals 0. I want to collect the like terms as well as do my regular adding or subtracting with my integers, with my whole numbers. So 3x minus 2x gives me x. 12 minus 2 gives me positive 10 equals 0. So what number adds to 10 to give me 0? Well, we can find that out by doing the opposite, by subtracting 10 from both sides. And that will give me x on its own here, equaling to minus 10. Now with this last question, there was a couple of ways we could have gone about this. We could have cross-multiplied. Some of you may have learned that. I don't like this strategy personally, but that would have worked to give you the same answer. But I wanted to do it in this way to show you how much freedom we really have with solving these types of equations. We can move any terms around that we need, and I wanted to do it in this way so we could practice our skills of adding and subtracting algebraic fractions. But that's it for this video as well as the topic. Thank you so much for watching, and I'll see you next time.